All right, let's get this thing done. This is try number 4 of this same video. It's now 2.5 hours I've been working on shooting one video, and man, I hope I get it right this time because I'm running out of patience. So let's just get going. Today we're going to talk about geometric series, and you did geometric series and sums of geometric series last time using Google Sheets. We could use Google Sheets, and if I mess up this video any more times, we might just use Google Sheets. But there is one more thing that you should learn about series and sequences. It's how to calculate an actual sum of a geometric series. First and foremost, make sure you know what a geometric series is. A geometric series is like 5, 10, 20, 40, where it has a common ratio. In this case, the common ratio is 2, because the bigger number divided by this, well, not bigger divided by smaller. 10 divided by 5, for example, is 2. So my R value is 2. All right. Next, there are 3 formulas. At this point, I'm starting to be content by just copying, pasting them, and I'll try to explain them as I go, because this is try number 4. I'm tired. I need some more coffee. But the 3 formulas are going to be a reminder of the explicit formula for a geometric series. The middle one and the right one are going to be 2 brand new formulas. Instead of even dealing with what they mean, the only thing I want to focus on is that the middle one is for finite series, a series with a fixed number of terms. And the one on the far right is going to be for an infinite number of terms. So this is going to be an infinite series. So 2 very different things. Let's keep going here. It is worth mentioning that the one on the right talks about this word called converging, and I have that word written down here because you do need to know what converging is. At this point, let's dive into converge versus diverge. A converging series is a series that adds up to be a specific number, and I have an example down below. If you see a converging series or a converging sequence, what you have is that numbers that continue to get smaller each time. You have an R value that is less than 1, and this pink is an example of a converging series. It starts at 3. It has an R value of 1 divided by 3, so it has an R value of 1/3. That's less than 1, that's why it's converging. And notice how it's 3, then 1, then 1/3, then 1/9, then 1/27. It has that same geometric series. However, the numbers that I'm adding, 1/3, then 1/9, then 1/27, they keep getting smaller and smaller. And as I get more of them, they get smaller still. They're going to get smaller forever and ever and ever. And no matter how many of them you have, as you have more, they get tinier and tinier. And interestingly, if you had an infinite number of these values, they don't add up to infinity. They actually add up to, this example, adds up to a really uninspired 4.5. So there's a formula to figure out what those numbers all add up to. It is kind of cool because it's one of the first things that deal with limits that we've dealt with so far in Algebra 2. You're going to deal with the word limit and this idea of summations a lot in pre-calc, but that's next year. So let's move on, right? This is a converging series. We're going to work on converging series. A diverging series is a series with an R value that is greater than 1. The numbers get bigger each time. I have an example here in pink. 3 times, well, here's the R value. The R value is 3, and you could see that these numbers 3, then 9, then 27, then 81, they get bigger each time. And if they're going to get bigger each time, we can't predict how big they're going to get. We only know they're going to keep getting bigger and bigger and bigger, which means the sum would be something more like infinity, right? So the limit for this would be infinity. Add them all up, you get infinity because they just keep getting bigger. We're not really working with diverging. I just want to make sure you know the difference between them. And now let's get into what are only 3 examples. So example number 1, I've already copy and pasted the formulas from up top down below so that we can work with these things. And here's the question in blue. 5 plus 10 plus 20 plus 40, the whole way up to 20,480. What does that equal? And it doesn't feel like that should take 3 hours to make a video about this. So let's figure out what's going on here. First, in the decision on whether this is a finite or an infinite series, this is a finite series because there are only so many numbers to work with. So I'm just going to ignore the infinite option at this point. I could probably even just delete it if we needed to, because you know what? The less we have to look at, the better. So let's deal with these 2 formulas only. Let's deal with the explicit formula first, and here's why. I know that this 5 is the a sub 1 term, and this is the a sub 2 and a sub 3 and a sub 4 terms, But this is the a sub, I don't have any idea term. I don't know how many terms there are. So instead of a sub question mark, I'll do a sub n. And we have a formula for a sub n. A sub n is a sub 1 r to the n minus 1. So let's write some stuff in. So 20,480 is a sub 1, which is 5. The r value is 2. We've already established that. And the n minus 1, I don't know what n is, so n minus 1. And let's just be clear that the n that shows up here and the n that shows up here and here and here is the same as the n that shows up in the next formula that we're going to use as well. So we need to know that n value because it's important for our whole problem. So let's go ahead and drill down on this. A couple things I know how to do from like pre-algebra. I could divide both sides by 5, and I've done this problem so many times at this point. I know that 20,480 divided by 5 is 4,096. That's a cool little fact. I also know that I have no idea what n is, but I do know logarithms. And I can write log base 2 of 4,096 is n minus 1. We're going to review logarithms as we go. You might want to just take my word on it for now, and hopefully that looks like something you've seen. Now, I also know I have no idea what log base 2 is, and I have a calculator, but it doesn't do log base 2, so I'm going to do the change of base formulas, which is log of the 4,096 divided by log of the 2 is the n minus 1. That I can do on my calculator. So I'm going to go ahead and figure out log of 4,096 using my calculator. So log of 4,096 divided by log of 2 is 12. All right, that's easy. So I'm going to put that back off to the side here. So I have 12 is n minus 1. Remember, that was just the change of base formula. Add 1 to both sides. And now, relatively easily, I figured out that n is 13. So now I know there's 13 numbers in this series. I can go back up here, and now I can start to calculate the sum of the first 13 terms, right? Because now I'm really just working on this brand new formula. Brand new for today. This is the sum of a geometric series. So here we go. The sum of a geometric series is the first term, and in our case, the first term is 5. So 5 times 1 minus the r value. The r value is 2. Because 2, right? Any of these numbers divided by the 1 before it is 2, so that's where the r comes from. And 2 to the n power. We just spent all that time calculating 13. Okay? We're going to divide by 1 minus r. 1 minus 2. Unless I'm wrong, I just literally typed this into my calculator. So one more time, let's go to our calculator. And we're going to type all this in. Now let's clear out the old stuff. I've got 5, well, I want the top, so parentheses, 5 times 1 minus 2 to the 13th power. That's my top. Divided by 1 minus 2 is just negative 1. I guess I didn't need to type that in. And there we go. So 40,955. So the sum of the first 13 terms in this geometric sequence is 40,955. Truthfully, that didn't seem all that bad. So it's kind of a funky looking formula, but we just kind of put our stuff in. And once we had all the information we needed, we used our calculator and we figured it out. So cool, right? I don't know why that took 4 videos to make, but it did. Maybe the second part gets a little harder. I'm at 9 minutes already, but I haven't messed it up yet, so let's keep it going. Example number 2 is a sigma. It's a summation. It's a geometric sequence. I can see that because I have a common ratio. My common ratio is 1/4. So I know my r value is 1/4. I know my starting value is 2. And I know the entire formula is 2 times 1/4 to the n power. Now, because I've tried this so many times, I do want to make sure that you know what we're doing here. We're literally just taking the formula and putting a 0 or a 1 or a 2 or a 3 and so on up to the number 20 and just adding all that up, and we're going to have 21 terms. 21 terms because we start at 0 and we go up to 20, so that's 21 terms, right? So we're going to have 21 terms here. So as long as you're clear on what we're doing, if we really had to, we could just calculate that. But we could probably do it without. We could use that new formula. Right, here it was, for finite sequences. We know that we have 21 terms, so I'm going to grab this piece right here, And let's go ahead and, well, let's get rid of that line. And let's go ahead and just plug some stuff in. So the sum of the first 21 terms is going to be the first term. So 2 to the 1/4 of 0 is 2 times 1, which is 2, right? So 2 goes on top. 1 minus the r value is, well, the r value is right here. The r value is 1/4. So no calculating required. And 1/4 is to the n power. This is where I've messed this up a couple times. The one time I messed this up, I grouped this and then put 21, and that is not a good move. That caused me all kinds of difficulties. It's part of the reason why I'm shooting this video again. The one, see here, it's the r that goes to the n power. So my 1/4 is the thing that has to go to the 21st power. That's key, and I'm going to be very careful about that. Divided by 1 minus, and I guess it's good to know, where to mess this up and where not to mess this up. 1 minus r, 1 minus 1/4. All right. This is, there's all just numbers here. Let's go to the calculator, right? If we go to the calculator, we should get an answer. I know what the answer is. I'm going to keep you in suspense until I type it all in. So let's go ahead and, no thanks. Let's go ahead and see if we can type this guy in. So parentheses, 2 times 1 minus parentheses 1/4, close the parentheses, to the 21st power. Let's close the parentheses again and again. And now I have my entire top grouped. I can see that. I'm going to divide it by 1 minus 1/4. This time I'm getting a little bit nervous about the fraction, so I'm going to use a decimal just because I think I've made it. And let's hope we get the right answer. Yes. All right. 2.6 repeating. This might mean I can get this video finally done with. So 2.6 repeating. So we're good, right? So what we find ourselves having is a finite answer. Now the truth is, I don't know if this is 2.6 repeating. If I had a calculator screen that was longer, maybe I would get more decimals, and maybe somewhere down the line it's actually not repeating, or maybe it changes to something else. All I'm sure of is on my calculator, with as many digits as I have to work with, I'm going to go ahead and say 2.6 repeating is a pretty good guess. I might say, if there's any sort of doubt whatsoever, I could say something like it's approximately, because I guess I don't really know what happens beyond that last 6. But again, I think we're okay. I think we can move on with confidence. And at 13 minutes, let's go and see if we can actually nail down our last example. So let's just summarize, though, before we get into the last one. And this also gives me an editing spot if I screw up from here on in. We've gone over what a geometric series is. We've talked about what the explicit formula for a geometric series is. That's this. We've talked about the 2 new formulas for today. The one for finite series, the one with a fixed number of values, and the one we haven't used yet, but guess what? Here it comes. The one for an infinite number of values that converges. And then we spend a little time talking about what converging means and how there's a way to figure out what the actual limit is of all of those summations. We did an example of a straight up series of numbers that was finite. We needed to use 2 different formulas. One to figure out how many numbers were actually in the series. We had to use logarithms there. That was kind of cool. And then we had to use our new formula for the for the summation of a geometric series. Second example, it gave you the summation. It gave you the explicit formula. All we had to do was pull the information off of there, shove it all into our equation, type it in accurately. This time I typed it in accurately and come up with a value. Great. By the way, don't memorize these formulas. You can look them up on your iPad. You can look them up in your book. If we have a quiz or test on this, which is probably what's going to happen, you can go back and you can look those up at that time. Now let's move on to example number 3. Example number 3 looks so simple. It really is. A couple things I want you to notice. First, this converges. It converges because our number values are getting smaller. The second thing that I would want you to know is that the r value, 1 divided by 2, is 1/2, right? And it's worth mentioning that even if I did 1/2 divided by 1, that's 1/2. Or if I did 1/4 divided by 1/2, that's 1/2. So my r value of 1/2 makes sense. It converges. We also know that it's infinite because we have the 3 dots and there's nothing beyond it. So this converging series is going to continue on forever, and we're supposed to add all of those infinite number of values up. It sounds like a really difficult task because there's no end in sight to how many numbers there are. Thank goodness we have what is actually a pretty easy formula. I'm going to scroll back up to our formula for the sum of converging geometric series that are infinite. I'm going to grab this guy, I'm going to bring it back down, and this problem is as good as done. Really, the hardest part of this problem is recognizing what we just did. It converges, the R value is 1/2, and it's infinite, so we know what formula to use. I'm going to paste this right here, and let's go ahead and calculate our sum, right? So the sum is going to be a sub 1, our first value, 1 minus our R value. Our R value is 1/2, so we end up with 2 divided by 1/2, which ends up being 4. We're done. As simple as that sounds, we're done. And if you actually think about what we're doing here, let's look at our numbers, right? 2 plus 1 is 3. 3 plus half is 3.5. 3 plus a quarter is 3.75. The next one would probably be 1/8. We'd probably get like 3.8 or 3.9. But so we're getting closer to 4, but every time we get closer, the number that we're adding on keeps getting tinier and tinier and tinier still. That, one more time as we wrap up this video at almost 17 really lengthy minutes, that is the concept of a limit. So while this video took me 4 tries, almost 3 hours of my life, and 17 minutes of you watching this thing, we've come to a cool place. We know what a geometric series is. We know how to calculate them using not only Google Sheets from last time, but directly using the formula. We know how to calculate sums of converging infinite series, which is pretty cool. We understand that there is a thing called a limit. While we might not be 100% sure what it is yet, we recognize there is a limit to things. We can converge to a limit, or we can diverge to infinity. And I think I made it. I think you made it too. So good job this week. There's going to be a few questions I'm going to have you try with this, and then it's the weekend. Go enjoy, and we'll see you on Tuesday.